Welcome to Blockchain Recorded, the podcast for the tech curious, where we talk about anything and everything related to the exponentially evolving crypto, blockchain, and Web 3.0 space. Our mission is simple: to share knowledge, facilitate discourse, and help evolve education in blockchain fundamentals, decentralization solutions, and relevant use cases for today's digital economy. We at Blockchain Recorded are not registered investment advisors and do not deal with financial or trading token elements, nor offer any licensed financial services. The content of this podcast is for informational and educational purposes only, while the opinions of all parties involved are their own. I'm your host, Nina Cerar, and now let's talk blockchain. Before we begin, this podcast is possible by our sponsor at Ambire. The Ambire wallet is one of the top products in crypto asset management. It is the first open source, non-custodial smart wallet that delivers exceptional user experience combined with solid security. With Ambire Wallet, users can easily navigate the world of Web3. It comes packed with features like built-in swaps, cross-chain bridges, integrated earning opportunities, and more. In addition, Ambire offers things like human-readable transaction parsing, eliminating ERC20 approvals and front-running protection. The smart wallet uses gas abstractions that allow for unique features like paying for gas with stablecoins. Users can batch multiple transactions to save time and gas fees. The wallet also supports NFTs and allows you to connect to any dApp via Wallet Connect. You can use it with an email and password or add hardware wallets or hot wallets as signers to upgrade your security. And the best part, Ambire speaks human. The UI is friendly and informative, ensuring you understand what you're doing and eliminating risks for mistakes. Ambire Wallet users are currently eligible for continuous wallet token rewards. To learn more and get your Ambire account today, visit www.ambire.com. That is AMBIRE.com. Today we're hosting Mathieu Baudet, the software architect and founder of the Linera Protocol. He's former blockchain researcher at Libra Novi and former software engineer at Facebook. Mathieu is a specialist in BFT consensus protocols, cryptographic protocols, and formal verification. He has experience in blockchain infrastructure, AI infrastructure, developer infrastructure, security consulting, and startup development. Mathieu, welcome to Blockchain Recorded.
Hi, thank you. Thanks for having me.
Thanks for coming. And judging or actually reading your background, you have a extremely rich computer science background, so very technical, with, I believe, over 9 years at Facebook. Is that correct?
Yes, that's right. Mm-hmm.
Yeah, so you were a blockchain researcher at Libra and also software engineer at Facebook. So lots of software engineering, and looking at your LinkedIn, you even had a PhD in computer science. Let's just start by having you take us through your background journey. But actually, before you do so, I just wanted to clarify quickly the meaning of BFT, consensus protocols. So that's BFT means Byzantine Fault Tolerance Consensus Protocol, for those of who are not familiar with the acronym. So Mathieu, with that in mind, please.
Okay. So personally, I've always been passionate about science, and in particular computer science, and maths. So my background, during my PhD, I started being serious about computer security, and I ended up joining a security agency, then a startup, and then Facebook, which brought me to California, and I spent there 9 years. First, I was a software engineer, and then I was a blockchain researcher in the blockchain project of Facebook, which was called Libra initially, and then Gem, and then recently I started Linera, which is really really a new adventure, and also rooted in the research I did at Facebook. So it's all very exciting. So you were asking about BFT consensus protocols. So I guess I can try to define that.
No, I was just trying to clarify, but yeah, go for it.
All right. Okay. So first, protocols are like programs that are meant to be executed in a distributed setup. So with lots of machines, right? Mm-hmm. And they are communicating over the network. So what can happen is you may want to know that the protocol keeps working if there are some kind of faults in the system. So it could be that some of the machines are crashing, or maybe the network stop functioning. And so BFT, Byzantine Fault Tolerance, is kind of the highest ranked, I would say, tolerance to faults. So where you resist not only crashes in disrupting networks, but you also want to resist malicious nodes up to a point. So perhaps a third or slightly less than half of the nodes that are participating to the protocols might be completely deviating from the protocol and trying to kind of attack everybody else. So it's a pretty strong security property, Byzantine fault tolerance. And now consensus protocol. So consensus is basically what you're trying to achieve with the protocol. And so in this case, and in the case of blockchain, so it means you have a protocol in trying to agree on something, on a number of decisions. And in the case of blockchains, that will be typically what is the next block in the chain of blocks. So yeah, so protocol to agree on things with a high fault tolerance against malicious nodes.
Great. So, well, and maybe further question in terms of your background, you were in mathematics, etc. So what after Libra, which was kind of a controversial protocol, but what brought you to Web3, or what brought you to where you are now, to Linera? Why Linera?
Okay. Yeah. Well, so first, I mean, I started Web3 when I was at Facebook. I transitioned from being an infrastructure software engineer to working in the blockchain project of Libra. And I don't know if we were calling it Web3, but I mean, I think that was kind of when I transitioned to the blockchain. And I would say what I liked is it was really a dream job for a computer scientist. I mean, and especially a specialist in computer security. And later on, I think also what interests me is really the challenges in scalability. And that sort of taps into what I learned as a software engineer at Facebook, and more generally, I think the culture of scalability in the Silicon Valley. Yeah, so I think this is really what I like with the Web3 and obviously the current project of Linera.
Yeah, we'll definitely get into scalability and low latency and those thoughts. But since you're an expert on blockchain networks, can you maybe give us a quick crash course sort of on the evolution of blockchain? I mean, we're familiar with it now, but it would be great maybe just from an early generation blockchain perspective to the latest, just for the newbies in our audience to have a better understanding. And just like you said, maybe it would be great if you could also clarify from the scalability and transaction finality point of view.
Okay. Okay. So that's a vast subject. But I think everybody by now is familiar with Bitcoin, which was the first widely successful blockchain, had such a massive success. And so in terms of evolution, you can probably trace back a lot of the attempts, at scalability, or in general, all the improvements in the fields. You can see that as an evolution of Bitcoin. So first, adding programmability with Ethereum, and I think lately there's a renewed sense that mass adoption is going to require much more performance, and so that is visible in the kind of protocols, the kind of blockchain protocols people are using, where we are transitioning away from proof of work and using this kind of protocols called proof of stake. And in fact, among the family of proof of stake protocol, those are based on Byzantine fault tolerance consensus protocols, which you asked me the definition for, are the ones that are gaining popularity these days precisely for the speed at which they can deliver new blocks, right? And so that's actually what the speed at which you confirm new blocks is basically what people call finality time. Although, of course, you can look at different details depending if you want to see, like from a point of view of the user, maybe the time it takes between the moment you take the decision and you sign the transaction and the moment you see the result. You could have several definitions there, but usually the important time is the time it takes for you to be sure that the transaction is included in the block.
So I kind of want to talk about blockchain scalability in general, since obviously you alluded it can be a problem. Can you maybe take us through and actually explain why is it so difficult to solve the scalability issue. I mean, we know now, like you mentioned, with Bitcoin and Ethereum and the bottlenecks and the network sort of slowing down. Why is that so difficult?
Okay. Yeah. Well, first, I think what's difficult is to sort of agree of a good definition of scalability, and I'm not completely sure it has always been the right one, the one in use by the blockchain community. And so you see some projects, for instance, advertising the number of validators, the number of nodes in the system. But if we look at other fields in computer science, more traditional internet systems, I would say if you want to be rigorous, yes, scalability would be first you have to define what people call a service level agreement, an SLA. So you need to define quality requirements, like what is the minimum speed at which transactions should be confirmed, or like the responsiveness of the user experience, right, on the interface. So you need to define some quality metrics. And then what you want is that this quality metrics, the experience of users, when there are more and more users in the system, just stay the same, right? Stay equally good. So that would be, and that's actually not very far from the actual way scalability is measured, and particularly the throughput is measured in traditional systems. You're looking at, like, you're trying to add user transactions to the system, and as long as the experience is not degraded for user, you keep going, and at some point you're like, okay, now we reached a point, and that's your measurement of the capacity of the system in terms of processing user transactions. And now, so the thing is, if you look at this kind of definition, definitely the original design in the field of blockchain are not really meeting this kind of definition. But I would say, maybe it's just also because they were not optimizing for that at the beginning. So it's difficult, but also because maybe just people were not prioritizing it at the beginning.
Well, and then this leads me to low latency, which is pretty crucial when dealing with fast finality applications. I mean, in terms of early generation blockchains, it was also challenging and very hard to achieve. And I imagine that if you want to add scalability to that, and with low latency, that's even harder. What's your view with this, and why is it important, and how do you see this being solved, or how is it solvable? And maybe sort of in layman's terms, just for the audience to know, latency, well, the way I'm seeing it is that latency means how long it takes for a node, right, to write the transaction to a blockchain. Am I getting that right?
Yeah, that's definitely one definition that matters.
Yeah.
In general, at a high level, I think where we're interested in is the responsiveness
Yes.
perceived by users, and so it can take different forms. And in the case of definitely in the case of a blockchain or a financial system, there's I could say an intermediate step where perhaps there's still a transaction is still going to be processed, but you already know it's final, and that's also very good to measure this kind of confirmation, like this kind of finality time. So why is it challenging, low latency? I would say in a decentralized system, so you have many nodes, and you want them to agree on what is the state of the system. So in the case of a blockchain, what is the chain of blocks? But then, so they need to collaborate, and you want them, you want all the blocks to be relatively large if you want throughput, if you want a high number of transactions, and there's going to be some constraints coming from the network, and so this is historically where the latency is introduced, just the sheer amount of networking that is needed to disseminate the user transactions, and then the overhead of a consensus protocol where you need to confirm the transaction. So there's a very rich dialogue between all the nodes where they want a very double, kind of triple check that everybody is agreeing on the next block. Yeah, traditionally where the latency would come, and also I would say even worse in the original systems based on proof of work. You in fact want the system to be slow, because this is what like the difficulty of the puzzles is what creates the security of proof of work blockchains. So in this case, this is even more a problem. But nowadays it's going to be more about the networking and the choice of a consensus protocol.
Yeah. Can you talk to some or about some low latency, maybe application specific use cases? Like we're talking about this now in theory, but maybe just put it into perspective.
Yes, I mean, well, so I guess it's for everyone to imagine what is going to be the killer application for blockchain in general and low latency blockchains. But I would say I like to compare decentralized systems with just the traditional centralized one. And if we look at a traditional financial system like a stock exchange, you can see that latency is extremely important for traders. In fact, to the point that trading companies are paying expensive rent to be very close to the servers of Wall Street, and so we know that latency is important in a traditional finance. If you're slower than the competitors, then you can be simply a front run, how they say. So you can be people will act on the information faster than you, and you will not make any gains.
Of course,
people could be also using kind of extracting information from the trades that are being processed and trying to also bypass you. This is called front running. So high latency in the financial system is not great. And so far centralized traditional financial systems are very low latency, and blockchains are the comparison with blockchain is a bit difficult for blockchains. So having a low latency decentralized blockchain, I think would enable a lot of DeFi applications. So that's one idea. Another idea also is just any kind of application where users are interacting with the blockchain, perhaps during a game, online game, and they will just enjoy the overall responsiveness and the user experience, the increased user experience.
I like the stock exchange example. It's we're shooting these terms, right? So latency, and then of course scalability, and it's hard not to allude to the blockchain trilemma, right? Which is a pretty well-known concept that was conceptualized by Vitalik Buterin in 2016. So that's for all the listeners that haven't not heard the term yet. It was conceptualized by him, and it addresses three main challenges developers face in creating a blockchain, or just in general, which are what we just talked about, right? One is scalability, the second one is decentralization, and the third one is security. So the goal obviously is not to compromise any of these three facets. Although the way Bitcoin and Ethereum started is that they basically started with trading off scalability, right? So putting decentralization and security ahead. But now the story may be different. How do you see the solution to this trilemma stand now in 2022 with all the upgrades going on? I mean, I know it can be a difficult question, but with the merge and et cetera. And how do you see this? Do you see a solution to this trilemma? Is there a solution? Is it even possible?
Right. Yeah. Well, so that's another big question.
It's a big one.
I would say so first, it always depends on on the meaning of each of the concepts. I mean, the what we put behind the words. So, for instance, scalability. If you don't need a low confirmation time, so low finality in layer one, then if you just want throughput and low fees, people who are working on ZK rollups, they really think they have it. Using the magics of cryptography and validity proofs, they are able to compress a large number of transactions into a short or constant size validity proofs, and that just need to be verified on the layer one. And so in this case, that is one of the favorite solution, I think, of the community. when it comes to solving the blockchain trilemma. Now, of course, I'm going to say, what if we actually care about the finality time in layer one, and perhaps because we are targeting some of the applications we just mentioned. And in this case, personally, my approach is to look again, how would we define decentralization, for instance. And in the past, oftentimes it's been understood as just the sheer number of validators. And with that definition, I do think you can't really have a low latency system at scale, just because the overhead of the coordination between a large number of validators with high throughput is going to not be sustainable, but to be hard to sustain. And also I would say large number of validators with commodity hardware also was the constraint that people have been really working and not really criticizing, not really second guessing so far. And so, but I think it's not the end of the story. There's room to investigate notion of decentralizations for large validators, and that's what we're doing at Linera.
But do you think it's solvable? I mean, okay, I know you said in terms of what the terms are behind scalability. So I don't know if you were just to say scalability, speed, and again, decentralization is a big one. Security, obviously, I guess, but if you were to have independent computers running on the network, is it even solvable?
I mean, I think I would say short answer. Nothing is impossible if unless you see a proof of impossibility, and then you would have to look at the assumptions of the proof and exactly what's behind all the terms. Sure. And I think ZK, like I said, ZK rollups. So like the kind of cryptography that is being developed is one example of something that looked completely impossible and seemed to be, in fact, increasingly becoming feasible. So and in fact, there could be applications of validity proofs beyond ZK rollups, for instance, to strengthen auditing and other kinds of systems, including low latency systems. So I'm personally I'm relatively optimistic, but of course there's still some work ahead of us.
Sure. Let's take a turn. What's your take on layer twos? Do you think that they solve, or they have the potential to solve the blockchain scalability issue, or are they just sort of a quick fix? Not to knock on layer twos, but
this is what I was saying, right? I think it's a amazing piece of technology, and it does provide a solution, a scalability solution, as long as latency is not latency. I mean, finality time in layer one is not a priority.
Okay, so let's talk Linera. Am I pronouncing that correctly? Linera? That's the
yes, Linera. Yeah.
So if I understand correctly from the research that I've done, you're building a new blockchain protocol with low latency, no mempool, and linear scaling that will be secured by proof of stake and run by fully auditable and accountable validators and internally sharded. That's a mouthful. Did I summarize that correctly?
Okay, yeah, that was a lot. This is a new so this is a new layer one that we are developing. It's based on research that started when I was a researcher at Facebook, and initially was only targeting large scale, low latency payments. So it was the original system. The ancestor of Linera was a research project for low latency payments, and so we kept the general architecture, which was I think really new and really interesting, and are generalizing this to allow to make it look like a general multi-chain system, and so, like as you said, the validators in Linera, what's interesting is that they are internally sharded. So it's a multi-chain system, and each validator has all the chains, and that's going to be a major difference if we compare to to a traditional blockchain sharding, where you have more like a collection of independent blockchains with different sets of validators. In the case of Linera, what we're looking at is validators that have all the chains. Each of them has all the chains, and they are sharded, but it's not visible from the outside. Pretty much like a normal internet service. You know it's sharded, but as a user, you don't know what are the shards.
And apart from that difference, where else do you differ from sort of the latest generation layer ones?
Yeah, so I mean, this is the main difference. The latest generation layer ones, what they are investigating is generally more how to optimize the latency and the throughput of a single chain, using really a number of engineering techniques, such as parallel execution. But they are considering a single chain and in which the user transactions have to be executed sequentially, at least from the point of view of the outside world. It needs to be a sequence of ordered transaction. And so that puts essentially a limit to how fast you can after you exhaust all the ideas, all the optimization. There's always a limit based on, like, for a particular architecture. There's always a cap on the transaction per second, because it's a single chain. And so in Linera, we are looking at a different problem. We are looking at how to have many chains communicate with each other extremely efficiently, and so that it's very cheap to add new chains. In fact, in Linera we want to make it possible, and in fact it's going to be encouraged for users to have their own chain, so that they can create new blocks and, for instance, move money out of their account by creating new blocks with extremely low latency, due to this particular setup where they own a chain, their own chain. So there are some really big differences. It's actually mostly complementary efforts, I would say.
And the concept of linear scaling, can you maybe explain that a little bit further?
Yes. So linear scaling, it's a term that comes from the world of databases, which also invented sharding initially. And so the idea is you start with let's say you have a database, and it has a lot of data on single machine, and then you figure, okay, that's too much for a single machine, so you're going to add another one. Another shard, okay? And the question is, like, as you add many shards to the system, do you have a diminishing return eventually because of maybe some overhead of communication, or can you keep adding machines and they are just you keep augmenting the capacity linearly in the number of machines, right? So is it true? So like linear scaling means if you double the number of machines at any time, you're doubling the capacity of the system with processing user transaction, right? So it's a form of horizontal scaling. It's the strongest form of horizontal scaling, where you ask scaling to have no diminishing returns.
Okay. And in terms of your validators, so as far as I could research, you're planning to use data centers for validation. Is that right? Feel free to speak to that. I was going to get to the decentralization part of it, but
yes. So in Linera, so what's Linera scalable? We want the entire system to be linear scalable, but the way we achieve that is by asking each validator to be also elastic, to be able to augment their capacity when needed, which means validators will have to either operate a data center or use a cloud provider to be able to meet this requirement that they have to be elastic. And so it's a different assumption. It's not commodity hardware, but it's still going to be very accessible, because we are going to provide the software for anybody to run in the major cloud providers. And in the future, I think if these architectures, as they become popular, I think we're going to see more and more cloud providers, perhaps some decentralized variants of a cloud provider that will be specialized in blockchain. But if you look at the number of cloud providers, it's already relatively decentralized. I mean, you got a dozen of them.
In terms of decentralized cloud providers?
It's already diversified, is what I'm saying.
Okay.
You already have a certain, like a large number of validators. I don't know if there are more major cloud providers than there are mining pools in Bitcoin, for instance. This is something you could look into.
Yeah, I think my immediate thought when you say cloud provider or, data center is, it's the, I guess, the problem of centralization versus decentralization, right? Of course, I think validators should be as decentralized as possible and independent and so on. How do you see this? Or do you think of this, or do you implement this? Or can you maybe talk to this in terms of being decentralized?
I think it's also really what people put behind decentralized. So initial blockchain systems were aiming at a large number of validators as a form of extreme resilience against nation states, for instance, that would try to disrupt or ban an entire blockchain. Right. So I think nowadays we see that when that happens, when a state, a government doesn't like a particular blockchain, they find other ways to ban the system, usually at the edge point, at the entry points. And there was a recent example in the news for a privacy system. So that's one aspect I would point out. And then it's not because validators are large that they are necessarily colluding. I mean, this is something I don't think has been researched enough, how to design the economics of a system where you have when you have large validators. Okay. So that's something we intend to do, studying the token economics and aligning, making sure that the incentives and of the system are favoring decentralization.
Yeah, you mentioned tokenomics. Is there a Linera token?
Not yet.
Oh, okay. There will be.
Yes, probably.
Or I guess this was my other question. You talk about interoperability in cross chains, et cetera. Will you, regarding the Linera interoperability with other chains, will you build bridges internally, or is this a concept that you have that you're already implementing?
So we haven't really started working on that. We're still at the building the infrastructure itself of Linera.
Okay.
So when the time comes, we'll see if we want to build the bridges ourselves or use existing solution for interoperability.
But you do actually, when you presented the protocol just at the recent blockchain conference, I believe it was at Stanford, you talked about, so you presented the protocol, and then the second point was cross-chain communication. So in terms of messages, Can you maybe talk about that?
I see. Okay, so in the presentation of the protocol, when I mentioned cross-chain communication, I mean communication between the chains of Linera inside Linera as a multi-chain system. Okay. And this is what we optimize for efficiency. This is really the core aspect of the protocol. The fact that cross-chain communication is so much more efficient because all the chains lives in all the validators. Okay. For the rest, when it comes to communicating with other blockchains, it's going to be pretty much as usual, I would say.
So, as I understand, Linera is not an EVM chain. So, will you need a native wallet when it comes to that?
Okay. So we haven't really communicated about the kind of virtual machine Linera will operate. Okay. I would say all the options are on the table, and even if we start with the particular option, we may also want to support EVM at the end. This being said, I think there will be a need for a native wallet in Linera, no matter what.
What else can you disclose about sort of Linera's roadmap, or where are you now with the process? I mean, I know you're building the framework. Is there a test net, or do you have a launch time frame yet?
Yes. So I mean, we do have an internal roadmap, but it's not disclosed. We still want to be able to adjust.
Sure.
Right. Uh-huh.
Okay.
But we do want to. I mean, our intention is to follow the normal track for layer 1 and have a dev net, then a test net, and so on.
Okay, so in terms of it's not disclosed yet. What is there? Will there be, or what will be the first application to sort of demonstrate the low latency features? I guess I'm just trying to get as much of a picture out as possible.
Yeah, so I think it's a bit early to say that, but as we are able to open source to share more of what we're doing. Mm-hmm. In the DevNet, I hope we'll find some partners, perhaps in DeFi. And personally, I'm really interested in what we can build on top of Linera for DeFi, and that could be really, I think, one of the first applications that show the benefits of super low latency at scale and in DeFi.
Mm-hmm. Okay. So in terms of your roadmap, you're not disclosing any of that yet. I wanted to actually, I alluded to this. You gave a talk at the recent Science of Blockchain conference at Stanford. I have to admit, I had to watch your presentation twice.
Okay.
I mean, no, it's just very technical, but it's a new direction, and it's extremely interesting, and I would definitely encourage our listeners to check out your presentation, and we can also include the link in our show notes if that's okay with you. What has been so I guess sort of after the conference, what has been the feedback so far in terms of going forward? Or there's also some questions at the conference. Just trying to. Yeah, there's not much information out, so.
Right. Yeah. So I mean, to set the expectations, it was indeed a scientific conference. So I gave a scientific presentation.
Sure.
And there were lots of interesting questions at the end. Yeah, I think the design, the science is really mature now. It's been, when you think about it, the first article on which Linera is based. So it's called FastPay. We presented it it was developed. So it was developed in 2019, published in 2020. So it's like almost 3 years ago, and that really helps, I think, presenting this new design, and we generalized, like I said, we generalized the initial ideas, which were only about payments. We generalized that to arbitrary applications, and I think it's a nice design, and the core idea in the end is relatively simple, I think, for when you I'm talking about the generalization from payment to arbitrary messages is something that at the end is perhaps simpler than we thought.
Mm-hmm. How big is your team? I mean, how many developers do you have?
Okay, so we're still pretty small. I won't say the number, but you can see on our website how many people there are, and we just hired one more, but we're still growing, we're still hiring REST engineers.
Great. So in terms of next steps, you seem very secretive. You can't exactly disclose too much. Where can people reach you? Or you said follow, in terms of following your information, you can check out your website. What's the best place to follow you and follow your work?
Yes. So the website linera.io. And you find also the Twitter and all the social channels. I just want to push back. We're not trying to be secretive or anything. It's just the roadmap is really what you would expect for layer 1.
Sure.
And it's just the timeline is we want just to be able to adjust the timeline.
Sure.
and not create frustration. And there's already a lot of expectations. People are asking actually on Twitter, when tokens.
Yeah, no.
So it's
we're definitely not in terms of, it's not for the speculation. I think it's just in terms of project wise and just knowing what your sort of what your next steps are. Yeah, no, we don't. When Lambo is not exactly part of our podcast. So, but just in terms of what we talked about, so we touched upon the latency and the scalability and in terms of the blockchain evolution. Is there anything that you wanted to add, maybe, or talk about that I haven't asked in terms of those questions, or also just in terms of Linera?
Right. I mean, like I said, we're hiring.
Okay. You are actively hiring.
We are actively growing the team. Yes, the engineering team. Other than that, I would say no. Thanks for all the great questions, and I was very happy to present the protocol and today.
Yeah, well, with Mathieu, this was certainly, I mean, it was an insightful talk. You are definitely in the beginning of the process. It certainly motivated me to brush up on blockchain fundamentals and technicals. And of course, it was great to host you. You're a very knowledgeable blockchain expert with a sort of a new direction protocol. I'm definitely looking forward to hear more about your progress. And maybe hopefully in a year or so, or 6 months, we can have you back and talk more about Linera. So thank you so much for your time and your work contributions to the space.
Thank you.
Thank you. Thanks again to our guest, as well as thank you everyone for listening. A big thanks goes to CoinMarket League for co-sponsoring this episode. Thank you also to the Barian Music team for providing their music. You can check out their latest album on barianmusic.com. You can find all supporting information on our website, blockchainrecorded.com, and listen to us on Google, Apple, and Amazon podcasts, as well as Spotify, Radio Public, and Stitcher. Stay healthy and tuned for our next episode.